calculus has been around for hundreds of years. It goes at least as far back as Newton and Leibniz. So to put it in perspective, when Bach was writing the Well-Tempered Clavier, that's when Newton and Leibniz were first developing their ideas that would become what we now know as calculus. So that brings to mind an interesting question. Why are we still studying it hundreds of years later? And what's the point of it in the first place? So one of the reasons we really liked this back when it first came about was because it allowed physicists to do these mathematical models that we now know as mechanics. And the most famous of this is probably orbital mechanics. So we were able to make early models of gravitation. We were able to, with great accuracy, predict the elliptical orbits of all these various planets. We're able to start tracking asteroids with great accuracy. Calculus can do many things, but those early physics applications were huge. And after it was invented, it still got developed throughout the ages. And some famous people who worked on it in the 1800s, Bernard Riemann worked on it. That's where we get the Riemann integral. And that progress in calculus kept on going and going and going, even into the 20th century, where we've got Henri Lebesgue introducing to us a new kind of integration that had big effects even on probability and statistics. So the applications of calculus are far-reaching. However, what we study in this course hasn't changed very much in 100 to 150 years, even though calculus itself has grown and developed, and we've got many, many, many applications. And so you might wonder, why is that? And you might wonder, what makes calculus so important? Why are we studying this? Why are we putting so much emphasis on it? And this is a question that I'll admit to you that many mathematicians don't like to get. I don't know the reason for that. But it is an interesting question. It's a serious question. And I'm not completely satisfied with the way that this is answered sometimes. So for instance, sometimes you'll hear from mathematicians, well, you should study calculus because it's so beautiful. Well, okay, I think it is beautiful. That's great. But I think that feeling of, calculus is so great, that sort of comes from people who already dedicated their lives to becoming mathematicians. You might not want to be a mathematician. I'm not here to tell you that, something is beautiful or not, or you should like this piece of art or that piece of music, or you definitely need to like calculus. So I don't buy that too much. Another thing that you hear is it's going to build your critical thinking skills. So you're going to come out being such a much better problem solver. I'm not sure if that's true either, frankly. And I think when you've got so many people taking this class year after year, and your older brother or sister took it, someone you know who's a little farther up the chain in age took it, and you ask them, hey, you took this class. Did you become like a great problem solver? Are you a much better thinker? Probably the answer is no. I took the class, and now I know calculus better than I did before. So I don't really accept that as a great answer for why you should study it either. Another answer you get is the applications. And there are lots of them. So if you know you want to be a mathematician, then, well, definitely you want to take this class. If you know you want to study physics, yeah, take the class because you need the math to do the physics. If you know that you want to study data science or machine learning or artificial intelligence, then probably you're going to need some of these algorithms, you're going to need the gradient descent method, you're going to need linear algebra. So yeah, you want the class, that's true. Other applications are more gray. So if you're going to med school or nursing school, you might be required to take this class or you might not. You might question whether or not it helps you. Or if you want to study chemistry, some chemistry classes require calculus, some of them don't. Is it going to help you? Well, I'm not here to solve that mystery for you. What I can do is, teach you calculus and not philosophize about it too much. But what I will say regarding the applications is sometimes what we're told doesn't quite match up with our experience in the class. So for instance, I was looking around at some online calculus courses, but while I was preparing this one, and I won't say which one it was, but I saw this great description, this great advertisement, why should you take our class? And it said, do you want to learn about how GPS works? Do you want to learn about how general relativity is used to make the global positioning satellites, to beam it all down to your phone and figure out exactly where you are at any time? Calculus can help you do that. And I said, really? That's amazing. I want to learn that. So maybe I should just take this course. So I scrolled down to the syllabus and I said, let's find the part during class when we're learning about GPS and satellites. And you scroll down the syllabus and it's the standard stuff. It's L'Hopital's rule, it's the limit laws, it's continuity, it's derivatives, it's the usual logarithm exponential functions, what we call early transcendental functions. And I felt a little bit let down. I felt like the advertisement didn't match the reality. And if I feel like that, you might feel like that too. So when you ask, if you do, what are we doing this for? I'll tell you, it depends on who you are and what you want to do for the rest of your life, but there's not one great answer to that, and I don't want to pretend that there is. I'll also tell you that there's no reason why this calculus class curriculum has to stay the same that it did for the past 150 years. If I knew exactly who you are and what you wanted, I could probably write a class from top to bottom tailored to your interests that'd be better. The problem is that I don't know that. And the problem is that if you take this class, you want to be able to transfer the credits anywhere. You want to be able to know that this class is at least as good as any other class you're going to take in college in America. And that I can promise you it will be. So I'll hit all the points that need to be hit. And for those reasons, the transferability and to make sure you have a great education that sort of fits in with the American system, I'll keep teaching it, roughly speaking, the way that it's always been taught. But that doesn't mean that it gives you the best motivation or it gives you the best reason to want to be interested. And I respect that. So what I'm going to try to do throughout the class is also identify some topics, some applications that maybe you're not going to see in a standard calculus book, that maybe go a little bit beyond, that I hope give you a broader picture into what you're going to see going forward. And maybe if I have time, I'll even make that video about calculus and GPS, because I looked it up. It is pretty interesting. It's actually a lot more than calculus, but at least we can do a little bit. So just keeping in mind, as you're going through the course, sometimes it's hard to see the broad perspective when you're studying this problem or that problem, especially when you get stuck on a problem. It's really frustrating. You're saying, like, why am I doing that? What I'll do is I'll ask you to trust me a little bit that I'm going to teach you things that are interesting, and hopefully I'll give you some real applications that are also interesting. So all that being said, let's get to work.